Hello, good afternoon, ladies, gentlemen, and teacher. I introduce myself. My name is David Aguirre Becerra. I am a student from Chemical Engineering at the University Tecnológico Nacional de México, Campus Orizaba. Today, I'm going to present what is the colligative properties topics, and I will explain what these are, and in the end I'm going to make a simple example about that. Um, this video is from Mother Physical Chemical 1 with the teacher Prof. Arturo Figueras Carrillo. Okay, people, we have started with colligative properties. What is it? Okay, the colligative properties are attributes of solution which depend on the number of particles in a volume of the solvent. They are related to the concentration, not to the mass or a typical of solution particles features. In Colling properties are called those properties of solution and their components that depend only on the number of not volatile solution molecules in relation to the number of solid molecules and not on the naturals. We can see an example about that I speak. An example with a solvent in the picture. This, and in this other picture we can see an examples about colligative properties, because that so it are 7 colligative properties, and we are seeing in the next presentation. To begin with this, it is the term colligative. This comes from the Latin word colligatus, which means unit and refers to the onion-on relationship between the properties of a solvent and the concentration of a solute in a solution. The Germany that this chemical William Oswald was to the first people in introducing the concept of colligative properties in 1891. This name arose in his work on the properties of solution. Friedrich William Oswald was born on September 2 in 1853 in the city of Riga, which at that time was part of Russian Empire and today is the capital of Latvia, in a family of Baltic Germans. He studied at the University of Dorpat, graduation in 1875. He worked as a professor at that center until in 1881. From 1881 to 1887, he was a professor at the Regal Polytechnic Institute. In the 1887, he moved to the University of Leipzig as a professor of physical chemistry. They founded the Oswald Institute, the first institute dedicated to the study of a cycled chemical, which he directed until his retirement in 1906. Okay, I speak you and exists seven uh, propi seven colligative properties. The first is osmotic pressure. What is it? What is osmotic pressure? Is it related to the concept of diffusion and osmosis? It is defined as the dilution tendency of a solution that is separated from the solvent via um, semi permeable, no sé cómo se traduce eso, membrane. The solute exerts osmotic pressure when faced with the solvent. If it cannot pass out of membrane, that separates them. Okay. Okay, we can with that the osmotic pressure of a solution is equivalent to the mechanical pressure that is needed to prevent the entry of water when it is separated from the solvent via semi-permeable membrane. And the osmotic pressure we can see him in with the osmometer osmotic. Okay, with the number two we have the ebuloscopic elevation. Okay, the name también es the boiling temperature of liquid. Okay, the boiling temperature of a liquid is that which its vapor pressure equals atmospheric. Any decrease in vapor pressure will produce an increase in boiling temperature. The rise in boiling temperature is proportional to the mole fraction of the solute. The increase in the boiling temperature is proportional to the molar concentration of the solute. The boiling constant, the name is Ke, is characteristic of each solvent. It does not depend on the nature of the solute. An example, the boiling constant, the water, it's valued in 0.52 grades centigrados and mole kg. This means that a molar solution of any non-volatile solute in water exhibits in boiling elevation of 0.52. Okay, the boiling elevation is related to the boiling point of a liquid. The boiling temperature is one whose vapor pressure is equal to atmospheric pressure. If the vapor pressure decreases, there was an increase in the boiling temperature. This elevation is proportional to the mole fraction to the solute. And that is all for the number two of that. Okay, we continue with the next property of that. And the property is cryoscopic descent. What is it? The cryoscopic descent is related to the freezing point of a liquid, el punto de líquido. The freezing temperature of the solute is lower than the freezing temperature of the solvent. Okay? The freezing occurs when the vapor pressure of the liquid equals the vapor pressure of the solid. The freezing temperature of the solution is lower than the freezing temperature of the pure solvent, and we can see that in tables, in pictures. Fusion occurs when the vapor pressure of the liquid equals the vapor pressure of the solid, calling Tc. The cryoscopic decrease and m, the molar concentration of the solution is called Kc, is the cryoscopic constant of the solvent. For example, for the water, this value is 1.86 C mol kg. This maintains a molar solution M equal 1 of any solute in the water pressure at less 1.86. And to end the colligative properties, we have a solvent vapor pressure drop. What is it? The vapor pressure of a solvent drops when a non-volatile solution is added to it. Okay? Decrease the number of solvent molecules of the free surface. Attractive force appears between the molecules of the solute and those of the solvent, making their transformation to vapor more difficult. In In simple words, when we add more solute, lower vapor pressure is observed. Therefore, the decrease in vapor pressure of the solvent in a solution is proportional for the mole fraction of the solute. The vapor pressure of a solvent drops when a non-volatile solution is added to it. This effect is the result of two factors. The number one decreases the number of solvent molecules of 3, the, the appearance of attractive force between the solute molecules and the solvent molecules making their passage to vapor difficulty. The more solute we add, the lower the observed vapor pressure. The mathematical foundation of this fact is Pixel B. Raoult observation. And the relative decrease in the vapor pressure of the solvent in a solution is proportional to the mole fraction of the solute. And we finish it with the properties, and we are going to explain um, how to work that and a simple example for that. Okay, for finish that work, I only say is many of properties of true solution are derived from the small size of the dispersed particles in general. Substance with a molecular weight of less than 10 elevated 4 daltons from the solution. Some of these properties are a function of the natural solute. Other properties are depend on the solvent, although they can modified by the solute surface tension, reactivity index, viscosity, etc. etc. In a dilute solution, it's that no matter what particles they are put, how many there are. For example, dissolving calculum calcium chloride, I can that okay. CaCl2 completely produce three particles, one calcium ion and two chloride ion. On the other hand, if we dissolve tablesat of chloride, sodium chloride, NaCl, we will obtain two particles of sodium and one particle of chloride. Another simple example is adding alcohol, a volatile liquid, to water. In this way, the freezing point at both alcohol volatile liquids to water. In this way, the freezing point at alcohol or water normally has is reduced, which is why alcoholic beverages are not usually frozen in a domestic refrigerator. Okay, and now I'm going to present a simple example about that. Okay, to finish the presentation, we are going to do a simple exercise. Okay, what is say? Calculate the boiling temperature of a 0.029 m. M is a molar aqueous solution, so es una cosa, in sodium chloride solution. Okay, the data of that is M equals 0.023, and that subjects we can obtain in tables. Okay, the first object is key A, that is boiling constant. In this exercise, boiling constant is 0.522 Kc is a coefficient of freezing. In this case is 1.86. Pe is a boiling point, and Pc is a freezing point uh, from the water, because we are in aqueous solution. Um, okay, and in the first part we need calculate that estímulo de C. Okay, and we can do it with this equation, Kc multiplied m, and that it's equal a 1.86 que multiplica a 23. Okay, that's it equals 0. Vamos a ponerlo acá. 0. 0.053 grados centígrados. Okay, that is the first part. Okay, now for the second part, we needed that. And we need to calculate DC. Just you have PC menos okay, and okay, that is DC and right. And when we do the operation, that is the request.